Hi everyone, my name is Urvin and I'm making this video to demonstrate my task 5.3 HD in which we are required to call a function from a web to device. So here in this task we are required to build an embedded system to remotely access our traffic lights and controlling them through a web page and involving the use of database as well. So let's deep dive into it and how this implementation has been done. So first of all, I would like to explain. It is all possible because of the Arduino Nano 33 IoT because it has an inbuilt Wi-Fi module, which is the Nina W102, and due to this we are able to connect it to the database. So now let's talk about the database. The database we are using is the Google Firebase, and it is a real-time no non-SQL database which can store the value in the JSON format. So this is the cloud database where we store the string values, and those string values will be updated via web page, and those those string values will be fetched by the Arduino. So we'll talk about that also. And there's an HTML page that is dedicated for controlling those LEDs remotely, as I said. And we have the Arduino sketch that refreshes after every 500 milliseconds to get the readings from the real-time database. And we have also studied about the Google Firebase in our last semester as we have we are more familiar because we can fetch the JSON values from the Firebase to the Arduino and even send the Firebase values to the web page as well in the front end part. And these are some components that I have used: Arduino, Firebase, LEDs, that is the Wi-Fi module, and there's a HTML web page. So in this task, we have a constraint that we are required to use the Google Firebase, but but not any other library that is supporting the web functions. So the only two basic libraries we have used is the Wi-Fi Nina, which is to connect to the Wi-Fi. Another is the HTTP client to just get the to just connect to the HTTP for our web page. So let's talk about the system architecture now. Okay, so let's talk about the system architecture. Here we have our Arduino Nano 33 IoT. So first of all, what is done is this is our HTML website. In this HTML website, we have three options, and we are only able to select one at a time. And if we have selected that option, like suppose we selected red, then this value is updated in the Google Firebase, and it has a string type, which inside which it is written red. And then this red is fetched by the Arduino. This red is fetched by the Arduino, and Arduino thinks that if we are having this string, like particular there is a red string, then it fetches the red part, and respectively, if red is fetched, then the respective actuator will work. Suppose we have the three LEDs, red, green, and yellow, and it fetches the red string, and for that particular string, we have the red LED over here, and hence that red LED lights up. And if we remotely controls over here, then the respective string will be passed to the real-time database, and from that database the value will be fetched by the Arduino, and then the respective actuator blinks. So this is the whole working of the system. This is my system diagram. So let's move to the code part now. So here's first of all is the Arduino sketch we have implemented. This one is an constant to connect to our real-time database that we have set up, and this is my real-time database. These are the pins for LED, and in the void setup we have begin our LED set it up LEDs as successful, and then we have the Wi-Fi things to set up the Wi-Fi and to connect it successfully. And the main thing comes here is the client.get traffic light.json. So here we have a database in which we have a node traffic light which stores a type of string green, red, or yellow. So here we have that root. We start from the slash, then we have that node, and we have dot get here to get the value. in the node traffic underscore light. So here we have some string values. The status code tells us about if the code is 200 or 400. If the code is 200, it is a good code that we have successfully connected to the database, and hence it will set up all the LEDs first of all in the low, and we then have the response. In this response, in this response string, we will be storing our values from the database like red, green that I have told over here. These strings will be stored in our response, and the Arduino then uses the index of method. If that response dot index of, the response stores that string that comes from the database, and then dot index of what it is. This is a special function that we have used, which is a for loop, which is a linear search basically, and it returns either -1 or either 0. If if the value is -1, then it says that we haven't received the red string. Suppose talking about the red string, if the value is -1, it says we haven't received the red string, and if the value is 0, like the it is a true or a false. If the not equals to -1, it means we have received that red value, and hence we will respectively turn on that LED. Similarly goes for the green, for the yellow. Index of is a linear search basically. I have also displayed that code part in my assignment as well for further understanding what is index of. It's an inbuilt function. So we have a delay over here which is of 500 millisecond that Arduino gets their values after every 500 millisecond from the Firebase. So let's talk about our web page now. Okay, so this is our web page. We have used the internal CSS to make our page look good and have good alignments. We are using the style.css. We have implemented the hover effect and aligned the items at the center. We have changed the font colors. So here's our main website over now. We have used three radio buttons which are red, green, and yellow. We have that on click. Inside that we are using a function which is the set light, in which we will be getting the color like red, green, or yellow. So these are this there is a script to connect to get aware about the database, and hence we are using the internal CSS over here. Here's our title which will be displayed in the Chrome on the above in the tab section, and these are some of the credential that we are using for the real-time database that I have created in Google Firebase. So the main thing comes here. This is a function satellite that has been used over here. What it does is it gets it refers to the values stored in the node traffic light that I have shown you in the database, and dot set color, it sets only one color, which means because in a traffic light, 3 out of 1 is only usable at a time. So we will get one color at a time, like out of 3 we'll get a red, out of 3 we'll get a green, out of 3 we'll get a yellow. So here's a function that is responsible for controlling the LED, and this function updates the values inside the Firebase. Like if I select the yellow, then here it will come yellow, and if I select red, the string will turn to red, and this string will be read by the Arduino, and the respective actuator will blink. So let's move on to the working part now. So let's talk about the working side. So here you can see we have our index.html, in which we are using that setLight function that stores one radio button value at a time, and that string value is stored over here. You can see in this node the respective string value has been stored, and this string value is fetched by the Arduino, and hence respective LED is blinked. You can see over here. Let me turn on the light. So here you can see the respective string value LED it has its status as on, and if I select green over here, then the value is updated, and then you can see over here the value is fetched by the Arduino, and you can see the respective LED on. So if I select red, the red is updated in the database, and we have this is the whole working, and we have the remote access to our traffic light system from our laptop, and this device is used somewhere else. So that is how we are remotely accessing our embedded system or our traffic light system. Over here you can see. So this was our whole project. So thank you for watching.